All right, so let's go ahead and do number 12. Pick up where we left off. Make sure I got this all. So balance the following equation. This is a kind of a hard one. All right, so we've got K, PT, CL, NH3. Ooh, this looks like a polyatomic ion. Does it pass the test? Oh, yep, it's an NH3 over here. So it's a turkey. So NH3. Is this the same on both? So we can treat it as a unit. All right, so we got 2 Ks here. We got 1 K here. We got 1 of those. We got 1 of these. CL, we've got 4. CL, we got 2 plus 1, we have 3. And NH3, we got 1. And we got 2 here. All right, let's start with the NH3. We're definitely going to have to, well, actually, let's not. Let's start with the K. So we got 2 there and 1 here. So we got to put 2 here. And that changes that to 2. But that also changes it to 2 chlorines plus 2 chlorines, which is 4 chlorines, which is actually a good thing. All right, our PT is good on both sides. And next we have NH3. Oh wait, our CL is good. So we have 4 and 4 and 4. Our PT is good. We have 1 here, 1 here. Let's just double check everything. Our K, we got 2 Ks on this side. We got 2 Ks on that side. Everything's really good. Our only thing left is our NH3. We'll just put a 2 right here. And that gives us 2 here. So we're all balanced. Okay. So, check. How many grams of KCl will be produced if you start with 34.5 grams of NH3? Ooh, so we're going from grams of NH3. This is what we have. To grams of KCl. Now, we're going from NH3 to KCl, so we're going from one product to the other. The only way to go from one thing to a different thing, like one molecule to a totally different molecule, is mole-to-mole relations. So, let's get started. First thing we always do is write down what we have. Then we take what we have, the units, and get rid of them. I am recording. Hold on, sorry. All right, so we take what we have and we put it down here. So we have grams of NH3. And where do we want to go? Well, we need to go from NH3 to KCl. And if you want to change from one thing to the other, you want to go to moleville. So going to moleville. 1 mole of NH3 is blank grams of NH3. And so what you do is you look on your periodic table. Nitrogen is 14. And I'm going to get a calculator. Okay. So nitrogen is 14. And hydrogen is 3. So that's, well, it's 1, but there's 3 of them. So 3. So it's 17 grams for 1 mole of NH3. So now we're in moleville. So now we take what we have and we get rid of it every single time. And we have mole of NH3. Sorry, I wrote that. Let's fix that real quick. And what do we want? We want moles of KCl. Now, for mole-to-mole relations, we look at the balanced equation. So NH3 is 2 moles. KCl is 2. Now we are in moles of KCl. And so we take that, bring it down here. And we want grams of KCl. So grams of KCl. So 1 mole of KCl is how many grams of KCl? Well, potassium has a mass of 39, and chlorine is 35 and a half. So that's 73 grams. Now we eliminated all of our units except for grams of KCl, which is what we wanted. And we have 34.5 times 1 times 2 times 73. And we got 5,037 for the numerator. Divided by 17 times 2, which is 34. And that is equal to 5,037 divided by 34 is 148.14. So 148 grams of KCl. Woohoo! Alright, same process. Start with what you got, get rid of it, go to moleville, then go to mole to mole, then back to grams, and that's what you want. Easy peasy lemon squeezy. Alright, let's go to the next question. Carbon dioxide can be commercially prepared by heating chalk or calcium carbonate. How many moles of carbon dioxide can be produced when 3.05 moles of calcium carbonate are heated? So here's the equation. Let's make sure it's balanced. I don't see any numbers, so it might not be 1, 1. Yeah, it's balanced. All right. So what do we start with? 3.05 moles of calcium carbonate. All right. Step 1, get rid of what we have. And where do we want to go? Probably Moleville. Oh, look at that. How many moles of carbon dioxide? Absolutely, we want to go to Moleville. Oops, sorry. We were already in Moleville. Silly me. We were already in Moleville, so we want to stay in Moleville. And we want moles of CO2. Since we're already have moles, then we just need to go straight to mole. So moles of CaCO3 is 1. Moles of CO2 is 1. Because 1 here and 1 there. And cancel these out. So 3.05 times 1, that means 3.05 moles of CO2. And it makes sense because that's what a balanced equation tells you. It tells you if you have 1 mole of this, you're going to make 1 mole of that and 1 mole of that. That's what this is telling you. Take this one. If you have 2 moles of this, you're going to make 4 moles of this. That's what the balanced equation tells you. If you have 2 moles of this and 6 moles of that, you'll make 4 moles of that and 3 moles of that. Alright, so let's go to the next one. Aluminum hydroxide, popular reacted with the water. How many moles of aluminum oxide will be needed to produce 0.64 moles of aluminum hydroxide? So we start with 0.64 moles of aluminum hydroxide is this one. If you didn't know which one aluminum hydroxide is, then ask. Just ask. If I can't tell you, I'll tell you I can't tell you, but it doesn't hurt to ask during a test. All right. All right, that's what we start with. And some of you might be saying, but that's not what we're starting with. This is the end. But those are the actual numbers we have. So that's why it's what we start with. Whatever they give you a number for, that's what you start with. So 0.64 moles of aluminum hydroxide is what we start with. And what do we want to know? We want to know how many moles of aluminum oxide. So we are going to change products. So we need to get to moleville. And 0.64 moles, we have moles. We are in moleville already. This is easy, huh? Oops, I forgot the Al. OH3. And what do we want? We want aluminum oxide moles. Aluminum oxide is this right here. That's aluminum oxide. All right. So 2 moles of aluminum oxide, 4 moles of that. Cancel that out. And 0.64 times 2 divided by 4. 0.64 times 2 divided by 4 gives us 0.32 moles Al2O3. Yay! Okay. Acid rain. Acid rain is called when sulfur trioxide from smokestacks combined with water from the air. If 145 grams of acid rain were produced, how many grams of water must have reacted? All right, so we're starting with acid rain. 145 grams of acid rain. So you got to know which one of these is acid rain. Acids always start with H. It's sulfuric acid, also known as. All right. Oh wait, what am I doing, silly? Do the same thing we always do. Get rid of what we have. Grams of H2SO4. And where are we going to go? We're going to Moleville. And since it's moles with something else, it's 1 mole. And how many grams of H2SO4 make 1 mole? Well, sulfur is 32. Oxygen is 16 times 4, so 16 times 4 plus 32. And hydrogen is just 1, so there's 2 of them, plus 2. Ah, what have I done? No. Okay. So it was plus 2 is 98 grams. All right. So now we cancel out our grams of H2SO4 and we have moles of H2SO4. But what are they asking for? How many grams of water? Oh, shoot, we got to switch to water. Well, we made it to Moleville, so let's do mole to mole. And we want water. The only way to get somewhere is to use mole to mole. So, let's double check that this is, yeah, it's balanced. So, there's 1 mole of this for every 1 mole of that. And cross that off. Now we're moles of water, so mole of H2O and grams. Oops, I didn't have to write out grams. H2O. So 1 mole of H2O is how many grams? Well, you use your periodic table. Oxygen is 16, hydrogen is 2, so that is 18 grams of H2O. And 145. So everything's all crossed off, so we end up with grams of H2O, which is exactly what it wanted. How many grams of water must have reacted? So let's do our math. 145 times 1 times 1 times, that's an 18 if you recall correctly. I just wrote it badly. Gives us 2610 divided by 98 times 1 times 1, so 98. Gives us, I'm going down here, equals 26.6, and our unit is grams of H2O. So every 145 grams of sulfur reacts, or uses up 26.6 grams of water. React with it. All right, so there you go. There you have it. There you are. I hope it helped.